All right, guys, in this video, I'm gonna go over solving systems of equations in 3 variables. Now, it's gonna be a lot. It's gonna be a lot of work, so kind of mentally prepare yourself for this, right? This is challenging stuff, adding that third dimension with that letter Z. But I think you'll like it. I think starting to understand these problems, I mean, these are very high-level problems, will start to make you feel, stronger with your math abilities. Okay. Now, also, I try to keep my videos pretty short, no more than 15, max 20 minutes. This one might be a little longer just with how long a typical question is going to take. So just bear with me, but feel free to take breaks as you're watching or skip ahead or whatever you need to do to get through it. Okay. All right, so there's some stuff at the beginning. It talks about a little bit about how you would plot these points. You can see the X and the Y axis, which you hopefully should be really comfortable with. The new thing is this new third axis with the variable Z. All right, so I'm gonna teach you in this video how we're gonna solve different linear systems that have those 3 variables. All right, so every linear equation in 3 variables represents a plane. Go back to your geometry days, in 3-dimensional space. All right, so when we have a system of linear equations, each equation represents a different plane. And so the solution set is the set of all points where the planes intersect. Now, this is going to obviously be very different from when you guys were doing solving linear systems with just 2 variables, because we only had 3 different kind of outcomes. We had a single solution, which was a point. We had no solution if the lines were parallel, or we had infinitely many solutions when we had coincident lines, so lines on top of each other. All right, so I'm going to show you in these questions when we're going to have exactly one solution, no solution, many solutions. So it'll be a little bit different, but I'll try to help you kind of work your way through it. All right, so let's start first with looking at when we have a consistent independent system. So you can see kind of in the sketch in the blues or in the orange, the blue, and the green, that we have these different planes intersecting at that one point. So this is going to be a system where we're actually going to get a solution where we have an x equal to a value, y equal to a value, and z equals a value. All right, so the first thing I'm going to do is I'm going to try to eliminate one of these variables. All right, so I'm going to start by using 2 of the equations to eliminate it, then use 2 other equations, eliminate that same variable, and then you'll see kind of the work will start to feel familiar with solving a system with just 2 variables. All right, so I notice that I have this letter Z has a minus Z and a plus Z. So I'm going to use equations 1 and 2 to eliminate Z. I'm going to check my pen real quick here. Yep, I had a feeling. Okay, so I'm going to eliminate Z, and this is using equations 1 and 2. All right, so I'm going to write x plus 2y minus z equals negative 4.5. Then write the second equation, 2x minus 3y plus z equals 7. And I can go ahead right now and eliminate that z because they have opposite signs. If I add vertically, I'll get rid of that z. So that's going to be 3x minus y equals 2.5. Okay, so stick and hold on for that just a second, okay? Now I'm going to go to letter B, all right, or my second part, if you will. All right, I'm going to eliminate z again, but this time, right, I'm not going to use equations 1 and 2. I just use those. I'm going to use equations 2 and 3, or 1 and 3. Okay, so write down equation 1, write down equation 3, and this time we have to do a little bit of work because you'll notice I can't just add to get rid of those z's or subtract. So I'm going to multiply everything in that first equation by 2. All right, so that's going to give me 2x plus 4y minus 2z equals negative 9. Copy down that third equation. And now I can add them to eliminate z. It's 6x plus 5y equals negative 2. Okay, so now I have these 2 equations that I've just gotten. This first one, when I eliminated z with the first and second equation, and this second equation, when I eliminated z with the first and third equation. So I'm going to go and put those together over here. All right, so 3x minus y equals 2.5. 6x plus 5y equals negative 2. And now you can think of this as like you're solving a system with just two variables, like you practiced in the lesson before this and like you did in Algebra 1. All right, so I'm going to go ahead and I'm going to eliminate the x by multiplying this one by 2. All right, so that's going to give me 6x minus 2y equals 5. And then copy down that second equation. Now this time I'm going to use subtraction to eliminate because they're the same sign. So that's going to be negative 2 minus 5y, which is negative 7y. And 5 minus a negative 2 is really 5 plus 2, which is 7. That's going to be y equals negative 1. All right, so I found 1 out of 3 of those variables. Once I find that 1, what I'm going to do is I'm going to go back to that very first one that I found and that I labeled it part A. When I eliminated my variable z, I can plug in that y is negative 1, and that will allow me to find x. So I'm going to write 3x minus y equals 2.5. Replace that y with the negative 1. Now you should see that that's really going to become addition. Move it over with subtraction. So 2.5 minus 1 is going to be 1.5. Divide both sides by 3. 1.5 over 3 is the same as 1 over 2, or 0.5. All right, so now we've found 2 out of 3. We got one more to go. All right, but again, once we have 2 out of 3, you can go back to any of these, the first one, the second one, or the third one, and you can plug it back into any one you want. So I'm just going to use the first one, but it really doesn't matter. All right, so I'm going to plug it into, let's see, where's my most room? I guess right here. So I'm going to plug it into x plus 2y minus z equals negative 4.5. Okay, so x is 0.5, y is negative 1, and I'll go ahead and solve for z. So that's 0.5 minus 2 minus z. So 0.5 minus 2 is negative 1.5. Move that over with addition. Get negative 4.5 plus 1.5 is going to be 3. So z equals negative 3. I think I did something wrong. Oh no, that should be negative 3. My bad. There we go. I did do something wrong. That should be positive 3. That makes more sense. All right, so when you write your solution for this, all right, because you ended up having a value for each of these, you can go ahead and write this as my x was 0.5, my y is negative 1, and my z is positive 3. All right, and the way we write this is a consistent and independent solution, because we were able to find that one point where these three planes intersected. Okay, so that's kind of in a nutshell how we're going to solve each of these types of problems. Okay, let's do another example. Now you'll notice in example 2 that not all of the variables are present. All right, but it mentions right above in example 2 that you can still solve for all three even if they're not all present in them. So what I'm going to do first is I'm going to rewrite these equations, right? But I'm going to put placeholders for the things they're missing. So x plus 0y plus 2z equals 2. 0x plus 3y plus z equals 8. And then 2x minus y plus 0z equals 5. All right, so it's up to you on how you want to kind of approach this. I'm going to go ahead and to eliminate z using my first two equations. All right, so I'm going to write down x, I'll call this, let me label what I'm doing so you can follow along. I'll call this eliminating z using equations 1 and 2. Okay, so I'm going to write down x plus 0y plus 2z equals 2. 0x plus 3y plus z equals 8. So I'm going to multiply my second equation by 2, so I'll be able to subtract. So copying this down, I get x plus 0y plus 2z equals 2. 0x plus 6y plus 2z equals 16, and I'm going to subtract. So that's going to be 1x minus 0x is just x. 0y minus 6y is going to be negative 6y. That's going to be 0, right? My z's go away. And 2 minus 16 is negative 14. Okay? Now I'm going to eliminate with the some other two equations. All right, I'm going to, actually, you know what I'm going to do? Let me see if you see this. All right, so I just got this equation. X minus 6y equals negative 14. Take a look at this third equation in my original one, all right? Or you could look at this one, they're the same. What we should notice is that in that third one, in the system, it doesn't have a z. And so just like the one that I found, this one doesn't have a z because I eliminated it. So I can go ahead and treat that as if I want to go back to thinking it's like two variables. So I can eliminate x by using my new equation, so I'll do new equation, and equation 3. So I'm going to write down x minus 6y equals negative 14, and then 2x minus y equals 5. Multiply this first one by 2. That will make the ability to eliminate by subtraction a possibility. So copy down that next one. Make sure I multiplied everything by 2. I think I did. I did. All right, subtract. So x is gone. Negative 12 minus a negative y is really negative 12y plus y, which is going to be negative 11y. And then we have negative 28 minus 5. That's going to be negative 33, which is going to be y equals 3. Okay, so I found one of them, which in this example, I don't have all the variables in each of them. So now I can just plug these into the original equations here, right? Like this one, I can just plug in that y and find z. So I'm going to plug in 3y plus z is 8. Plug in y is 3. That's 9 plus z equals 8. So z equals 8 minus 9, which is negative 1. And then finally, to find x, all right, I could use, this original one again, or I know z now, so you can use that first one. It really doesn't matter. It's up to you. I'll use the 2x minus y equals 5. Plug in that y of 3. So you get 2x equals 8, or x equals 4. Okay, so writing my ordered pair, my x goes first, so I have 4, then my y of 3, then my z of negative 1. So just like that first example, we have an x, a y, and a z. These planes are all intersecting at one point, so this is that consistent, independent solution. All right, so hopefully starting to see kind of how this works. So again, right there, no free variables, one unique solution. The planes intersect at a single point, okay? All right, let's get a little more complicated here. So now what we're going to do, and you can see a summary of kind of the stuff that we're working with, and feel free to kind of adjust that as you go. But now what we're doing is we're going to have some more interesting solutions that happen. All right, starting with this first one, example 3. I'm not going to do all the examples. I'm going to do 3 more, 3, 4, and 6. I'm not going to do 5 because it's very similar to number 4. But you can check back later on Canvas. I'll have the key with that work shown. All right, so this one, what I'm going to first look at is I always check to make sure that these are not proportional, or that if they are proportional. What I mean is I notice after the equal sign, I see negative 9, negative 3, and negative 3. So if I were to multiply the second one and the third one by 3, you'll notice that that would give me that negative 9, all right, for those bottom two. But if you notice, when I look at this, I'm going to end up having not a proportion for any of them, all right? But you can also kind of, as you go through, you can take a look at the proportions if you compare two equations at a time. And I'll show you with the next example what I mean by that. But the point is that this is not proportional. All right, so when we think about what that does for our answer, is that means that we're going to, at this point, I'm going to continue with the same process. So I'm going to start with my first kind of step here, where I'm going to eliminate my letter y using the second two equations. So let me erase this stuff here. If you notice my second and third equation here, if I were to just add, I would eliminate y. So let's go ahead and eliminate y using my second and third equations. So write those down. X minus y plus z equals -3. -3x plus y plus z equals -3. So I'm going to add, because that would make 0 for y. Okay, 1 plus -3 is going to be -2x. The y's are gone. Z plus z is 2z. And -3 plus -3 is -6. Okay? We're going to do the same type of thing like we did before, where we eliminate y with two other ones. All right? And this time I'm going to choose the first and the third one. So I'm going to write 7x. Ooh, that's not a 7. Good try. 7x minus 5y plus 3z equals -9. Write down the third one, -3x plus y plus z equals -3. I will need to multiply to get to a place that I can eliminate. So I'm going to multiply this next one by 5. So copying it down. And what's going on with my 7s tonight? Jeez, sorry about that. There we go. 7x minus 5y plus 3z equals -9. Multiply by that 5. And we get a chance to eliminate by adding. 7x plus, forgot my x, -15x is going to be -8x. The y's are gone. 3z plus 5z is 8z. And then -9 plus -15 is -24. Okay? So like we had in that very first example, now I've gotten to a place where I just have two equations that have those same two variables. So I can go ahead and move them together, right? So it's right, -2x plus 2z equals -6, and -8x plus 8z equals -24. Now what you might have noticed at this point, or maybe not, is that if I were to look at those two, or I should say 3 coefficients in front of all those things, in front of the x's, in front of the z's, in front of the constants, you would see the proportions that I'm talking about. So if we have -2 over -8, I see 2 over 8, and I see -6 over -24, you can actually write equal signs in between all of these, because all those reduce to 1 over 4. So they're all proportional. So when this occurs, this means we're going to have one free variable. So we're going to write our equation for one of those variables. In this case, we're going to write them all to be in terms of that x. All right, so I'm going to write one free variable. All right, so we rewrite equation for one variable. Here's what I mean. All right, so what I'm going to do is I'm going to take this equation right here, and I'm going to write my z, I'm going to solve for z in terms of x, okay? So I'm going to write -2x plus 2z equals -6. Solving for z, so move the -2x over to become positive 2x, and then divide by 2 to solve for z. That's going to be x minus 3, okay? So we are writing that in terms of our z in terms of our x, right? So our solution, which we'll write up here in a moment, is going to have x. We're going to solve for y in a moment. And then we just found z in terms of x is x minus 3. Okay? So it's weird because you're not going to have any numbers for your solution. It's not just those numbers. There's going to be variables involved. Okay, now we do the same thing, but we're going to plug it in to find y. All right, so any one you want, I'm just going to choose the second one, but it doesn't matter. So I'm going to write, so now plug in to find y. So I'm going to write that second one, x minus y plus z equals -3. You might be wondering, Mr. Vander, why did you choose that? I try to choose ones that don't have a lot going on with coefficients when I do this. It'll make the simplifying a little easier. All right, so we have the x, we have the y we're going to be solving for, but we know z is now x minus 3. So I replace z with x minus 3, we just found that. Combine like terms, I get 2x minus y minus 3 equals negative 3. Remember, we're solving for y here. So I'm going to move the 2x over and the minus 3 over to get negative 2x. Adding that 3 is going to be negative 3 plus 3, which is 0. So dividing that negative over gives me y equals 2x. All right, so we write y in terms of x as 2x. Okay, so this is going to be our solution. You can see that this is not just a consistent independent solution. We call this infinite solutions. Not like there's anything, but infinitely many. Infinite, consistent, and dependent. So I will write consistent, dependent, and infinite. Okay, so that's one example or one case where you don't actually have a point that all the planes are intersecting on. All right, so we have our answer in terms of x. Okay, let's try another example. We'll do example 4. Okay, so in example 4, all right, I mentioned this earlier. If you look at all the coefficients for just the first two, so like 1 and 2, is 5 over negative 10, negative 1 over 2, 2 over negative 4, and then the constants are 3 over negative 6. These are all equal to each other, right? Those all reduce to negative 1/2. Let's see what happens when I look at equations 2 and 3. So I have negative 10 over 2.5. I have 2 over negative 0.5, negative 4 over 1, and then negative 6 over 1.5. And those all reduce as well to the same value of negative 4. So these are all equal as well, so all proportional. And so because that happens, right, these are actually going to be on the same plane. So each of these, when you get that all proportional, are going to be the same, right here, the same plane. Okay, so when this happens, we are actually going to have two free variables. So before, when we had that one free variable, we had x is in the answer, and then we use that to write our values for y and z in terms of that x. So now we're going to have x and y are the free variables in our solution. So you'll see our solution will have x and y. And then we're going to have our z value will be in terms of x and y. Okay, so I'm just going to use, again, it doesn't matter which one you want to use. I'm going to choose the last one because I'm ultimately going to solve for z, and that doesn't have a coefficient in front of it. So it'll be easier if I just choose that. So I'm going to solve for z, all right, and moving those over will allow me to get the last piece of this. So 2.5x minus 0.5y plus z equals 1.5. Again, I'm going to be moving both of these things to the other side. So when I do that, they become the opposite sign. So it's going to become negative 2.5x plus 0.5y, and then plus the 1.5. So that's all going to be my z and my answer here. Let me leave myself some space. So negative 2.5x plus 0.5y plus 1.5. So that is going to be, that rounds out the answer for this system. So again, you're going to write consistent, dependent, and infinitely many solutions. All right, but the idea is it's a little bit different because we have those same planes. Okay, like I said, I'm going to skip 5. All right, so you can check out the key for that one because my video is getting pretty long here, almost 30 minutes. Want to wrap up soon. Let's just do one more here, example 6. All right, and then we'll be finished. Okay. Now, when I go to look to see if it's proportional, right, you can write 1 over 2. You can write negative 3 over 4. You can probably already stop. You might already notice that it is not proportional, right? These are not all equal to each other, right? So we're not able to do the thing we did before where we had the multiple free variables, all right? Now, what you'll notice is that we don't have that third system here, right? Or excuse me, a third equation in this system. We just have two. So we're going to have one free variable because of that fact that we're missing one of these equations. So one free variable means we need to eliminate a variable to start. Okay, so let's go ahead and let's eliminate that variable z. You might have noticed it's the quickest one to eliminate just because it has a +1 and a -1 coefficient. So I'm going to eliminate z. All right, so I'm going to use, I don't have to specify which equations because there's only two of them. So write them down. All right, so I'm going to add to eliminate. That's going to be 3x plus y, that's 0z, equals 4. All right, now what I'm going to do, because remember, we have that one free variable, which is going to mean that I'm going to have x as part of my solution. So I'm going to rewrite this solving for y in terms of x. So y equals -3x plus 4. So that's going to be my next part here. And then to find what z is equal to, I'm just going to plug in that value, to plug in the y equals -3x plus 4 to figure out what z is going to be equal to. Okay, so rewriting my first equation. So I'm going to keep the x, replace the y with -3x plus 4, bring down the plus z and equals 1, distribute, you get 9x minus 12. Combine like terms, it's 10x minus 12 plus z. Going to be moving everything over that's not z to get -10x, and then 1 plus 12 will be 13. All right, so that's going to be my z. My last part of the solution is -10x plus 13. All right, so again, very similar to the ones that we had before. This is a consistent, dependent with infinitely many solutions. Okay, so hopefully you'll have a chance to practice some of these again. I know there's going to be a lot of work. These are very tricky, but I think once you start to get a couple of them, you start to feel pretty excited about the math you're able to do. So come see me if you have any questions. Good luck.